Imagine standing on the surface of Mercury. You watch the sun slowly rise above the horizon. Then you wait. You wait a day, a week, a month. The sun doesn't move. A single day on Mercury lasts 176 Earth days. You sleep through a full night on Mercury. Back on Earth, entire sports teams have already changed their head coaches. But the real torment begins when the sun finally reaches its highest point in the sky. You expect it to set. Instead, it stops. Then it starts moving backward, as if something invisible is pulling it in reverse. This isn't science fiction. It's not a myth. It's not spiritual symbolism. This is real physics, and only Mercury behaves this way. Mercury orbits the sun so fast that its orbital motion outruns its own rotation. The planet literally moves around the sun faster than it can spin. When physicists first calculated this effect, even Einstein reportedly doubted the math. And this is only the mildest of Mercury's abnormalities. What truly keeps scientists awake at night is what lies beneath its surface. A distorted iron heart that preserves the most violent memories of the early solar system. But first, you need to understand how extreme this planet really is. Mercury experiences the largest temperature swings of any planet. During the day, surface temperatures can reach 430 degrees Celsius, enough to melt lead. At night, they crash to 170 degrees Celsius. That's a temperature difference of over 600 degrees. Why? Because Mercury has almost no atmosphere. There's no blanket to trap heat. When the sun sets, warmth disappears instantly. And the suffering doesn't end there. You would face the sun for over 80 Earth days straight, before night finally arrives. Then you endure another 80 days of darkness. This brutal cycle turns Mercury into a true planetary hell. And yet, the real nightmare lies deeper. Mercury's iron core makes up nearly 75% of its entire mass. That's completely abnormal. Earth's core is only about 1/3 of its mass. Mars, about 1/4. If Mercury were a person, it would be a skeleton with almost all the flesh stripped away. The planet is small, just 4,880 kilometers across, smaller than some of Jupiter's moons, yet it has the highest density of any rocky planet. For decades, scientists argued over why. The leading theory once claimed that a moon-sized object slammed into Mercury billions of years ago, blasting away most of its outer rock in an impact equivalent to trillions of nuclear bombs detonating at once. But in 2021, researchers from the University of Maryland overturned that idea. The true culprit wasn't a collision. It was the sun itself. In the early solar system, the young sun acted like a colossal magnetic engine pulling iron-rich material inward. The closer you were to the sun, the more iron you accumulated. Mercury formed right inside this iron-rich zone. It wasn't battered into shape. It was born this way. The iron air of the solar system. But that iron core is still causing trouble. Mercury is slowly collapsing, like a great drawing into a raisin. A 2023 study published in Nature Geoscience revealed that Mercury's core is still cooling. As heat escapes, the entire planet contracts. Over the past 4 billion years, Mercury's diameter has shrunk by more than 7 kilometers. This contraction ripped massive cliffs across the surface, some rising several kilometers high, dwarfing any cliff on Earth. Even today, new fractures continue to appear. Scientists suspect Mercury may still experience planet-wide quakes, a world nearly 4.6 billion years old, still cracking and shifting like a newborn planet. And Mercury bears scars far worse than these. 4 billion years ago, an asteroid over 100 kilometers wide struck Mercury. The impact carved out the Caloris Basin, a crater 1,550 kilometers across. Shockwaves traveled through the entire planet. On the opposite side, the surface collapsed into chaotic, twisted terrain. Inside the basin, frozen lava flows still marked the aftermath like flames locked in stone. But Mercury was hiding another secret, one no one expected. In August 2024, scientists published a shocking discovery in Nature. Beneath Mercury's surface, near its ancient polar glaciers, there may exist a diamond layer 15 to 18 kilometers thick. Yes, diamond. Mercury's surface is unusually rich in carbon. Under extreme pressure and heat deep inside the planet, that carbon could undergo a phase transition, transforming from graphite into diamond. This hidden diamond layer may also explain why Mercury has a surprisingly strong magnetic field. Which brings us to another mystery. By all known rules, Mercury should not have a global magnetic field. Its rotation is painfully slow, one spin every 59 Earth days. That's far too sluggish to power a planetary dynamo. And yet, Mercury has a magnetic field. About 1% the strength of Earth's, but unmistakably real. In 2008, NASA's MESSENGER spacecraft found something even stranger. Mercury's magnetic field is riddled with massive holes. Solar wind punches through, slamming into the surface at rates 10 times higher than Earth. Which leads us to Mercury's most counterintuitive feature. Mercury has ice, not a trace. Billions of tons of it. At the bottom of deep craters near the poles, temperatures never rise above 170 degrees Celsius. Mercury's axis barely tilts, less than 0.1 degrees, so sunlight never reaches these crater floors. They are natural deep freeze vaults. Any water molecule that drifts in becomes trapped, accumulating over billions of years. In 2012, MESSENGER confirmed thick layers of ice, covered by a mysterious dark organic material. A planet once thought completely dead was found to hold both ice and organic compounds. Which forces scientists to ask an uncomfortable question. Is Mercury truly incapable of supporting life? Studies in 2020 suggested that chaotic terrains on Mercury may result from the release of volatile materials beneath the surface. If subsurface temperatures are moderate, combined with ice, extreme microbial life cannot be entirely ruled out. It's a reminder that life should not be defined by Earth's standards. Exploring Mercury, however, is brutally difficult. In fact, it's harder to reach than Pluto. Any spacecraft approaching Mercury is constantly accelerated by the sun's gravity. Fail to brake properly, and you either plunge into the sun or miss Mercury entirely. Only 2 missions have ever succeeded. Mariner 10 flew past in 1974, mapping less than half the planet. MESSENGER orbited Mercury from 2011 to 2015, finally completing the global map. Now, a far more powerful hunter is approaching. Launched in 2018, the joint European-Japanese mission BepiColombo is on its way. After 9 gravity-assist flybys, it will enter Mercury's orbit in late 2026. Its 2 probes will study Mercury's surface and magnetic field in unprecedented detail, collecting 10 times more data than MESSENGER. In January 2025, BepiColombo completed its 6th flyby, sending back images of permanently shadowed craters near the North Pole. Those dark crater floors may conceal vast hidden ice reserves. Mercury is the most underestimated planet in the solar system. It isn't a candidate for colonization like Mars. It doesn't have dramatic storms like Jupiter, but it is a keystone for understanding how planets form and survive. A world that holds ice inside fire, that continues to contract and quake in silence, that breathes slowly, billions of years after its birth. The next time you look toward the horizon at dawn or dusk, try to spot Mercury. It hides close to the sun, and behind that quiet glow lies the most insane planetary story we've ever uncovered.